Hello everyone, and welcome to another Tech Talk. Alma Linux 9.2 Turquoise Cod has just been released. It's an excellent choice for a drop-in, bug-for-bug compatible replacement of Red Hat Enterprise 9.2. That said, this video will not be a review of this server-oriented distribution, but instead a case study of sorts on how Alma Linux can be configured as an up-to-date, yet relatively stable personal workstation for development and containerized workflows. We'll dive in head first, right after this. Please keep in mind that none of what I'm doing today should be done on a server deployment, and certainly not in production. In the RHEL world, for desktops, GNOME appears to be the default environment. Not everyone prefers GNOME, so today I've chosen KDE Plasma LTS as the target instead. I've downloaded the latest KDE Live image, link in the description below, and so let's start the development VM now. So here's the boot screen for Alma Linux Live 9.1. I'm just going to boot into the default menu selection. So we should expect our live KDE environment. Very convenient for those of us who would like to explore different desktop environments on Alma Linux. Okay, so we've got the choice, welcome to Alma Linux, try Alma Linux, or install the hard drive. So let's install the hard drive. We'll launch the famous Anaconda installer. Welcome to Alma Linux 9.1. English is correct. Let's just click continue. This is the random access configurable installer, so I will just work backwards here to show you guys how this works. So my login name will be Steven. I'll give myself a good strong password. We'll click Done, which is on the top left on Anaconda, because it is random access installer, non-linear, right? Host name, I will use Alive1 or Alive1, since this is Alma Linux Live. For an installation destination, the virtual machine has VDA, 64 gigs, pretty standard. You can also encrypt your data as an option here. We won't do this today. Keep this video as short as possible. I'll click Done. And yeah, Los Angeles time zone is correct. English keyboard. Root account is disabled because I gave myself an admin regular user with the admin privileges. See, I can go into any of these settings again and just click Done on the top left. It's at the top left instead of the bottom right, like a traditional linear installer, to keep things less confusing. So we'll go ahead and install. And shouldn't take too long at all, depending on your network speed. So it's installing, downloading, installing all the packages, configuring the installed system, creating the users, the initram file system, and we're finished. Just a little reminder, use of this product is subject to the license agreement found in the following directory. So we'll look at that in a bit. Let's finish and restart the virtual machine. And see if installed correctly. We'll let it boot to hard disk. And standing by. They've got a little spinner here. There we go. So initial setup, licensing. License information, license not accepted. So let's click on that. So the Alma Linux 9 EULA, it comes with no guarantees or warranties of any sorts, either written or implied. The distribution is GPL version 2. So and a copy of the license is included. So that's good. We're on our own here. That's perfectly fine. So we accept this license. Finish the configuration. And we should be going into the SDDM Display Manager shortly. And here we are. Give it my password. and this is the Wayland session. We'll be switching to X11 session later on in this video. That's what I like to do for OBS and other projects. Let me launch the console, and let's make the font size bigger so you guys can read more easily. Let's check a look at the OS release file. Yes, we have updates available. So we're currently running, that's the latest live image, is still running version 9.1 of Alma Linux, Lime Linux. And so as you can see, we've got to do some updating here. Let's check the Plasma version, KWin version. Shows we're running KWin 5.24.6, which is last year's LTS release. The year is 2022, last year. And the kernel is also from last year, 5.14, compiled Tuesday, November 15th, 2022. So yeah, we need to do an update of this system. Let's upgrade to Alma Linux 9.2. So I've become root. But before I do the update, let's fix the DNF configuration file, because I like to enable max parallel downloads equals 10, right? This will help with the total download time and better use my internet connection. So now we can do a DNF update -y, allow erasing, because we're doing a version upgrade, which means we want to avoid conflicts of packages. So we like to allow erasing, because it wants to remove the Plasma Discover software manager, because there's a conflict between 9.1 and 9.2. So they'll break the Discover program, as you'll see in a bit. So it's got over 800 packages to download, lots of updates to go from Alma Linux 9.1 to 9.2. So as you can see, it removed AppStream Qt and Plasma Discover Flatpak, Notifier, libs, and PackageKit. And there you go, the icon's broken now, because we have removed Discover. So let's reboot. We'll fix Discover later on in this video. Don't you worry. So let's boot, hopefully now, into Alma Linux 9.2. And here we go. That was pretty quick. Let me log in. So as you can see, of course, Discover is still broken. To be fixed in a minute. Let's launch the console and see what's what. So let's check the OS release file. Okay, so we're on 9.2, Turquoise Cod. So that's the latest version. And perfect. So it looks like the upgrade was successful. Let's check the Plasma shell version is still 5.24.6. If you're happy with this version, this is last year's 2022 LTS version, then that's great, but we're going to upgrade. The kernel is now a more recent kernel from this year, May 9th compiled, 2023. So yes, we've upgraded the kernel and a whole bunch of system packages, over 800 of them. Good, looks like our upgrade was successful. But we need to fix some things. So let's become root. Yeah, Discover still has a broken icon there because it's missing. So let's first upgrade KDE Plasma to this year's LTS release. So in order to do that, let's DNF config manager set enabled the code ready builder formerly PowerTools, repository. So we can enable the enterprise packages for enterprise, or extra packages for enterprise Linux repos, the EPEL release, and also for the latest desktop environment, we also want to enable the EPEL Next release. We're definitely off the beaten path here. It's not recommended that you use this repo for Alma Linux, but as we'll find out momentarily, or at least I hope, this will work just fine. So we're installing the keys here, key imported, everything is successful. Let's do a quick DNF update -y, and let's bring our KDE and other dependencies up to date, to a more recent version, so the packages are not quite so stale. So now there's 600 packages to download. So we'll let that happen. Okay. So as you can see, of course, Discover is still missing. So, but before we fix that, let's reboot. And hopefully we can enter our new KDE LTS, or the latest LTS for 2023 environment. So here's our SDDM. We put in the password. Okay. So let me enter the console here, make the font size bigger, go to full screen. So let's check our Plasma version, kwin -- version. So now instead of 5.24, we're now at 5.27.4, this year's LTS version for KDE Plasma. So a lot of bug fixes. I prefer this over the older one. It just works better, I think, 5.27 or 5.24. Lots of fixes. So let's become root, and let's do a DNF install -y Plasma Discover. And that should reload all the programs we need. And sure enough, did you see that in the bottom left? We have our Software Center, Discover Software Center, back from the dead. So let's launch it. That's better. Cool. So we're fully functional again. Let me go to settings. I use OBS Studio. I'm using OBS Studio for this video. So I like to use the Flatpak version. So this is the list of currently enabled repositories for Discover. Let's add the aforementioned flathub.org option or repository. So that's a central Flatpak repository, flathub.org. So we just have to wait a few seconds here before it becomes active. There it is, Central Repository of Flatpak Applications, dl.flathub.org. It's that simple, folks. Let me go to All Applications. As you can see, Flatpak's already enabled. Very nice. Let me go to OBS and hit Return. And there's our OBS Studio. So if I were setting this workstation up for recording, I would download this OBS Studio from the FlatHub repository. You get the latest and best fixes for OBS. It's fantastic. But we won't do this. This video is long enough as it is today. So, moving right along, I just want to show you guys that Discover works. Let's configure the our KDE desktop. So let me go to Breeze Dark so my retinas don't burn out. Let me go and configure 1080p. There it is. And let's increase the global scaling to 125%. so things stay legible. The fonts get a little blurry. We'll have to log out and log back in again to fix that. But before we do, let's turn off energy saving, because this is a demo and I don't want the screen blanker to come on during my demonstration, right? So let me go to screen locking and turn off the automatic lock screen. Wonderful. Okay, let me close settings. Let me log out and log back in again, putting in my password. And instead of Wayland, let me switch to X11 so I have global hotkeys enabled on OBS. That still hasn't been fixed for Wayland and OBS. So I'm using X11 in general for my production machines still. Looking forward to Wayland though. Okay, of course we're now in the X11 session, not the Wayland session, so I'm going to have to fix the global scaling again. So 1080p is still there. Let's do 125%, like we did before. With X11, now we have to log out and log back in again for the global scaling to take effect. So here we go. Please bear with me, everybody. Logging out, and then logging back in again to the Plasma X11 session. Here we go. That looks better. Nice and crisp. And hopefully legible for everybody. On phones it's kind of small. I'm sorry about that, but this is the way it is. Okay, KDE Plasma 5.27.4. And yeah, we still have this kernel version. So if this kernel version works with your hardware, just leave it as it is. But if not, I will show you how to update to the mainline kernel, Linux kernel. So here's Alma Linux's homepage, very attractive to my eyes. So I strongly encourage you to read through and contribute and be part of the community. A Firefox browser, of course, is like all RHEL compatibles, is 102. Whatever, extended service release. Not surprising at all. So back to our project. So for the kernel, there is the EL repository, or the Enterprise Linux repository. And part of this project is, if we scroll down, is the EL repo subrepository, where they provide your choice of kernel long-term or kernel mainline packages that have been compiled for your convenience. So today, let's take a look at the kernel mainline. And so they give you instructions on how to install it. We'll do this momentarily, but I want to draw your attention to these notes here. We provide these kernels for hardware testing in an effort to identify new updated drivers which can then be targeted for backporting. Meanwhile, these kernels may provide internal relief to people with non-functional hardware. Again, if your hardware functions with the kernel we have now, don't do this. But if you want to run a mainline or a long-term kernel, this is what you have. These packages are provided as is, so no warranty, express or implied, the usual. But really important for you to keep in mind, the default Alma Linux kernels are signed for secure boot. The EL repo kernels are not signed for secure boot. So if you want to use these kernels, turn off secure boot on your machine. Remember this, because otherwise it will fail to boot if you install these kernels, because they're not signed for secure boot. Okay, so we've got the console here. Let's do the deed and install the latest mainline kernel. Let's become root here with sudo-s. Let's do a DNF install elrepo-release. Yep, so now we have the Enterprise Linux repo available to us. So if we do a DNF repo list, you can see we have EL repo, Community Enterprise Linux Repository, available now. So now that the main EL repo repository is available, let's try DNF install kernel. Just want to show you guys something here on how you can pin the kernel. So if you do install kernel-ml, you can see there's no package match for kernel-ml because we have to enable the EL repo kernel subrepository with first with DNF --enable repo equals EL repo -kernel. So that makes it active. And then we can install kernel-ml and the latest version is, you can specify the version here, 6.3.2. They include the last two releases, so 6.3.2 and 6.3.1 in this case. As you can see, now we have the proposed installation for these three packages: the kernel, its core, and its modules. Three packages. So let's import the GPG key. So it installs three packages and also the scriptlets. Looks like the installation was successful. So with fingers crossed, let's reboot. Okay, and boot from the hard disk. Aha. Okay, so far so good. Let's log in to SDDM. All right, we have our desktop back. So let's go to settings, about the system. And look at this. So 5.27.4, the latest KDE LTS, and also the latest mainline from the EL repo, version 6.3.2. Success. We've upgraded the kernel. Again, don't do this if your hardware runs on the standard Alma Linux kernels. But let's just say you're running super new hardware and you need the latest kernel. This is an option. Again, it's a non-standard solution, but there you go. If this doesn't work out for you, if the new kernel doesn't work out, you can do a DNF history and then sudo DNF history undo change with the ID equals 8, and then you can roll back your kernel install. DNF is wonderful when it comes to the history database. So, okay. So that's how you can get out of that bind if the kernel gives you trouble. So, sudo DNF install DistroBox, because we want to run containers here and develop containers, and also virt-manager because we like to test virtual machines also on this workstation. So let's go ahead and install DistroBox, which is a great front end for Podman, and virt-manager to test when we'll build an ISO, an Arch ISO later in this video. So we need a virtualization solution to test the ISO. Okay, sudo systemctl enable, now please, our virt-manager with libvirtd service. And so that sets us up and enables the daemon immediately. So if I test virt-manager, it'll ask for the our password, and we're connected to the QEMU KVM host, which is running on this virtual machine. So right now we're nesting virtualization, right? So virtual networks, we've got a pre-configured active virtual network. It activates on boot. as the network address translation, and also a default file system directory storage pool. We'll just leave it like that because this is not a virt-manager video. We'll just leave it configured all default. We're just doing this as a demonstration. So let's get out of virt-manager and let's move right along. Let's create the home directories, separate home directories for our DistroBox Podman containers. So I'm going to make 2 of them for the demonstration today with make-dir-p tilde dbx, which is our DistroBox home directory parent directory, archroot, and Ubuntu. Those are the 2 containers, one root container, one standard container, root enabled rather, that we'll be demonstrating today. So DistroBox create -- image Ubuntu, and we'll use the 22.04 tag for the latest LTS version of Ubuntu. We'll call it Ubuntu with a capital U. And we'll designate the home directory for this container as tilde my home directory /dbx/Ubuntu. That looks good. Image is not found, so you can hit return here. Don't have to type Y. So it'll pull the image and let's it sets up the container for us. The Ubuntu container. That didn't take long at all. So for user level containers, it'll put the container in the start menu for you. So let's launch it. And it's done. All right, we're in our container, Stephen at Ubuntu with a capital U, /home/Stephen, which is our host home directory. So cd and return puts us in our container home directory. Very important that we always do everything from our container home directory so we don't mess up our host home directory. Keep things nice and clean, right? That's what containerization is all about. So you can see OS release shows we're running 22.04.2 Ubuntu LTS. And I'm checking for apt package updates. Make sure our container is up to date. Looks like we got 4 package updates. So when that's done, let's move right ahead and let's do a sudo apt install build essential, because I want to use this Ubuntu container for some basic development, right? So build essential should be your minimum package install for this scenario. Okay, let it install all the packages. This will take some time depending on your network speed. And here we go, and we're complete. So build essential should be installed, because now what I can do is install a Rust development environment using rustup. So I just curl and then this shell.rustup.rust, and we'll run the installation script from the rustup site. Here we go. So you can see it sets up the path environments and everything. So it puts the profile and bash RC modifications in the correct home directory for this container. Let's proceed with the installation, which is the default. Again, we're doing a trivial Rust example here, just to show you guys that, how it might work for you. So to configure your current shell, run source home cargo env for environment. So let's do that. Okay, that's done. All right, so let's clear the terminal here, and let's do a rustc dash capital V shows we're running latest available Rust version, Rust compiler version 169.0, compiled April 16th. Cool. Let's do a trivial hello world example with cargo new hello Rust. There it is. Created the binary application hello Rust package. So let's go into this directory that we just created. There's our cargo.toml file and the source directory. So we should just be able to do cargo run. And there's our hello world. Perfect. So that works. So let's install Visual Studio Code. And run Visual Studio Code from within this container. So let me go to the Visual Studio Code site. It's code.visualstudio.com. And here we go. So we're running on Ubuntu, which requires a Debian package, not RPM. Even though the host is AMA Linux, we're in Ubuntu. So .deb is what we need. AMD 64 is our architecture. Good. So it's downloaded to our host home directory downloads. So that's done. We should have our Debian package now in the host downloads directory. So let's try to install it. So sudo dpackage-i/home/Stephen/downloads. Again, this is outside the container where the package is. And then this file, code.1.78. So it's going to unpack it. And it's going to try to install it, but there's some dependency problems and configuration is unfinished. So let's fix this by doing a simple sudo apt-get -f install. So that'll pull in Visual Studio Code's numerous dependency packages here, dependent packages that it needs. So let it do that. So now code should be available from within the container. So Visual Studio Code should have access to all of our development container for Ubuntu. So code dot in our Hello Rust project. I won't go through theming. As you can see, theming needs to be fixed. I'll just leave it because this video is long enough anyway. So I'll trust everything, trust the authors, trust all files in the parent folder. So we'll just do that. We won't do the get started. We just do these things very quickly here for demonstration purposes. Let me install some extensions for Rust. So I like to install Rust Analyzer. And it's done, installed. Next, let me install the extension for TOML, Better TOML, that's what I like. Seems to be very popular. Let's go ahead and install Better TOML for TOML language support. And then the extension Rust syntax. Seems to be also pretty popular. Let's install this one as well. And there we go. I think all our extensions are installed that I'd like for today. So let's go into the source directory and click on main.rs. And here we go. Now let's just click run. And as you can see, Visual Studio Code runs our trivial Hello World Rust project. Cool. If I click on cargo.toml, I should get nicely formatted, syntax highlighted TOML editing. As you can see, that works as well. I think that is success for Visual Studio Code running inside a container, has access to everything. Don't have to worry about the containerization because code runs within the container. So let's log out. We're done with the Ubuntu container. It's still running in the background. Notice I have not shut the container down. I won't throughout this video. I will not shut down any containers. I just want to show you the power and low overhead of containerization. Much more efficient than virtualization, full virtualization. Let's install the Arch root level container with distrobox create --root --image. It'll be Arch Linux, which is the latest usually by default. We'll call it Arch root because this is a root level container. And the home directory for this container shall be under dbx arch-root. So if we hit return here, it will ask us for a password because this container needs to be root access because I like to build the latest Arch ISO in this container. And it will, part of the building the Arch ISO is it needs to mount and unmount file systems. So it needs a root level. It won't touch the host Alma Linux system, so don't worry about that. I just want to demonstrate the effectiveness of containerization when you want to build, say, an Arch ISO. Okay, so we've entered into our Arch container. As you can see, it's Stephen at archroot. Stephen, let's change into the home directory for Arch root. Here we go. Let's check the OS release to demonstrate to you guys. I'm not cheating here in any way. So OS release shows we're running Arch Linux in this container. It's, of course, a rolling release, unlike the host Alma Linux system, which is a traditional release model. Also, we're running the host Alma Linux kernel from EL repo 9.632. See, that's what makes containers have such low overhead. You're sharing the kernel from the host system. So let's make sure our Arch container is up to date. Looks like it is. The usual stuff. If you're familiar with Arch, you know what I'm doing here. So let's install Arch ISO. We select to build an Arch Linux boot ISO for installing Arch Linux. So once that's done, let's go ahead and copy the release engineering configuration from user share Arch ISO that we just installed, configs, relang, and in our container home directory, we'll copy it to Arch Live. Because then we can go into Arch Live directory. And if we do an ls, you can see we've got our packages, file, and everything that you need if you want to customize your Arch ISO. We won't go into that here. We will just create a default latest Arch boot ISO. In order to do that, we'll create the working directory, work, and the output directory for the ISO called out, right? Then all we have to do to build the ISO is sudo make Arch ISO -v for verbose. Working directory -w will be work. And for -o for the output directory will be out. And then for relang, we'll just put dot for the current directory. And this is a pretty hefty virtual machine. We're doing nested virtualization. Again, QEMU KVM is wonderful. It's really close to bare metal hardware speeds. And yeah, if you want to test Linux and develop Linux installations and software, QEMU KVM Virt Manager is your friend. Or Cockpit if you prefer. And look at that, it's all done. Pretty cool. So this is our output. Here's our ISO file. So let's test it with Virt Manager. But in order to do that, I have to copy it to the pool for Virt Manager, the default one that we've set up. So sudo copy output directory /archlinux.blah.iso. We'll copy it to var lib. If you recall, that's where our pool is. libvirt images. And there. So now that's done. What I'm going to do is log out of our container. Still running. Archroot is still running. And we're going to launch Virt Manager. Give it our password. So that's ready. Let's create a new virtual machine. Local install media. Forward, browse. There's our ISO we just copied into the pool. var lib libvirt images. It detected, auto-detected, it's Arch Linux. So I'll just go stick with the defaults here to make this as quick as possible. It's just a quick demo. We'll just create the domain. We'll just stand by. Again, this is nested virtualization. Keep this in mind. The host is a virtual machine itself. Okay, here we go. Arch Linux ISO. Looks like it's booting. Fantastic. Welcome to Arch Linux. Arch Linux aficionados should find this very familiar. And here we go. Arch Linux 632. This is the Arch kernel, not our host kernel, which happens to be also 632, but that's just a coincidence today. This is a Virt Manager virtual machine, QEMU KVM. Set font Terra 128N. We even have networking running. So looks like we've got a successfully built the latest Arch ISO. See how easy that is? You don't have to download it anywhere, just build it yourself, right? Okay, so that means we've got the latest Arch install installation script if you prefer doing that. Let's check the version. That's 2.5.6 as of today, the publication date for this video. 2.5.6 is the latest available. So we can just do an Arch install. Don't worry, we won't install Arch today. I just want to show you that we've got a fully functional ISO. You can see the script is working, as far as I can tell. This is what I do when I create Arch Linux install videos, is I create Arch ISO using this. So let's shut down this virtual machine. This has been successful. Let's go ahead and close this and close that. Wonderful. Okay. We've been very successful today so far. It's amazing how flexible Linux is. So let's do a sudo dnf install ps_mem. So I want to show you just how little overhead our got two running containers running in the background. Just how little overhead we have. We have shut down the virtual machine, the nested virtual machine, because the host, again, is a virtual machine itself, right? So sudo ps_mem. So you can see this is a 16 gig virtual machine. We've got a whole bunch of stuff running. PSMem shows you how much each process is using in terms of memory, private, shared, etc., etc. So this is good. PSMem is a great little utility for showing you where your memory is going. So Podman is using a total of 12.9 megabytes, as far as I can see. I mean, we've got two running containers, right? And but we still have very little overhead. So containers are using like over 99% of the resources, and Podman's using 1%. So if I do a DistroBox list, we've got our Ubuntu container, LTS container running. It's up for 28 minutes. And let's do a DistroBox list --root, so we can see we're running our Archroot container. It's been up for 12 minutes. It's our newer container, But both of these containers are running nested within our host virtual machine. And all of this is running on a tiny Minisforum little desktop machine. Very modest machine, not very expensive. This whole video has been running on that inside a virtual machine. So fantastic. So this is Turquoise Cod, completely updated to the max, blinged out with the latest KDE and DistroBox and virt-manager for testing virtual machines. So there you go. That was a quick and dirty demonstration of what can be done. Some say nothing is impossible with Linux, and I'm inclined to agree. If you made it this far, thanks so much for watching. Please smash the like button and subscribe. Cheers, and until next time, take care and have lots of fun.